Hi everyone, and welcome back to Matthew Wizard. Today we're going to cover systems of equations in algebra. So to start off, systems of equations is a set of two or more equations that share the same unknown variable. The goal is to find the values that make the equations true at the same time. So there's two ways of solving for systems of equations. There's the graphing method and then there's the algebraic method. So when you're graphing, you want to take the two equations and graph them on your calculator and see at what point they intersect. And wherever they intersect, that's going to be your solution. But now algebraically, you can do a few different methods like substitution, elimination, or setting both equations equal to each other if they're equal to the same thing. So let's do a practice problem. So this first problem, we see that both equations are equal to y. So if they're both equal to y, they're also equal to each other. So we're going to set these two equal to each other. So we're going to have 8x minus 3 is equal to x squared plus 4x minus 15. Now that we have this, pay attention to the fact that we have a square. We have a quadratic here. And whenever we have a quadratic, if we want to solve, we want to set it equal to 0. So the easy way, in order to keep this x squared positive, we're going to take what we have here and bring it to this side so that then it's equal to 0. So we're going to do minus 8x and then plus 3 because that's the opposite. We're going to do minus 8x according to the corresponding terms. And we're going to have x squared. 4 minus 8 is negative 4x. And then negative 15 plus 3, we're going to have negative 12. And that's going to be equal to 0. And now that we have that, we can just solve. We can factor it. So we're going to do the x and the box method. So first we need to multiply our a term times our c term. And that's going to be through the box method. So x squared times negative 12 is going to give us negative 12x squared. And those two have to add up to negative 4x, which is the middle term. So we need to find factors of negative 12x squared that add up to negative 4x. So let me list out a few factors. We have 12x and 1x. We have 6x and 2x. We have 4x and 3x. I'm just going to stop there. So since we have a negative, we need to have at least one of these have to be a negative. And when combined, they have to add up to negative 4. So 12x and 1x wouldn't work because these values are too big. So that wouldn't count. Now, if we have 6x and 2x, that could work. Because let's say we have a minus 6x plus 2x. Because if we do minus 6, negative 6 plus 2, we're going to get negative 4. So that could work. And 4x and 3x, that would not work because these values are too big. The values that we're going to use is negative 6x plus 2x. So negative 6x and 2x. So now that we have those values, we're going to put it in the box. So in the top, we're going to put negative 6x, which is here. And then in the bottom, right across from it, is going to be 2x. But now, in these other boxes, we're going to fill back in the a term and the c term that we started with. So x squared and negative 12. And now we just factor. So we need to find two factors between negative 6x and negative 12. And that's negative 6. And then what multiplies to negative 6 to give us negative 6x? That's x. And then what can we multiply to negative 6 to give us negative 12? That's going to be 2. And then what can we multiply to x to give us x squared? That's going to be x. And then we can see here x times 2 is going to give us 2x. So we're left with x plus 2, because this is positive, and negative 6 plus x. And you can also just rewrite that as x minus 6. And that's going to be equal to 0, because again, it's a quadratic. So it's going to be equal to 0. And then we're just going to solve. So x plus 2 equal to 0 is going to give us negative 2, because negative 2 plus 2 is going to give us 0 because they cancel each other out. And the same thing for x minus 6 equals 0. That's going to give us x equals 6 because 6 minus 6 is just 0. So now that we have our two x values, we need to plug them back into at least one of these to see what the corresponding y coordinate is. Now, when we're doing this, right, we want to pick the equation that's going to be easiest to do. So I'd say we pick this one because this one, you see, there's just more work there's more numbers to plug in. So let's plug them into here. So let me just make some space. So I'm going to erase this. So we have our little table. If our x value is -2 and if our x value is 6. So we're going to plug this in. So y equals 8x, in this case is -2, minus 3. So 8 times -2 is -16. And then -16 minus 3 is going to give us -19. So that means that our y value is -19 when our x value is -2. So our coordinate is going to be -2 and -19. But now if x equals 6, we're going to have y equals 8x, which is 6, minus 3. So 8 times 6, which is 48, minus 3 is going to give us 45. So y is going to equal to 45 when x is 6. So our coordinate is going to be 6, 45. And these are our two solutions. And if you want to check your work, you can go in the calculator and you can graph both of these equations in and look for the intersection. And if you graph it and the intersection points are -2, -19 and 6, 45, then you know these are the solutions. So this example here was a way of doing it algebraically by setting them equal to each other. So now in this problem, we can see a circle being graphed and a line being graphed. And they have two intersection points at 3, 4 and -4, -3. So what we're trying to do is, again, solve for the system of equations. We need to figure out what the final coordinates are that make x and y true. So this time, they're not equal to each other, but there is something we can substitute. So here we have y isolated, right? And if y is isolated, we can easily substitute it in to the y in this equation. We get rid of the two variables, and this way we can just work with x. So we're going to have x squared, that stays the same, plus y squared. Now, since y, according to the second equation, is x plus 1, we're going to rewrite that as x plus 1 squared, which is from here, is equal to 25. Now that we have that, we're going to do some side work. So let's figure out what x plus 1 is simplified. So we have 1. So x times x squared, x times 1 is 1x, and x times 1 again is 1x, and then 1 times 1 is 1. So we have x squared, 1x plus 1x is 2x, and then plus 1. So we're going to rewrite that. So x squared plus 2x plus 1 is equal to 25. Now what we can do is we can first add the terms. So we have 2x squareds. So we can add that to get 2x squared plus 2x plus 1 is equal to 25. So again, here we have a quadratic. So we have to set this equal to 0. So by doing that, we need to subtract 25 because we want to keep the x squared positive. So we're going to bring that to this side. So we're going to minus 25. We're going to get 2x squared plus 2x minus 24 is going to be equal to 0. Now, there are a few ways you can solve this. I'm going to show you the way that I like to do it. So I'm going to do the box method. So I'm going to get my x. I'm going to multiply 2x squared negative 24. So 2x squared times negative 24. I'm going to get negative 48x squared. And they have to add to the middle term, which is 2x. So what factors of negative 48x squared add up to give me 2x? Well, I have 6x and 8x, which can work together. If I do 8 minus 6x, that's going to give me 2x, because 8 minus 6 is 2. But also 8 times negative 6 gives me negative 48. So I'm going to write that negative 6x and 8x. Now that I have that, I'm going to put this into our box. So in the first box, we're going to put negative 6x. And in the box right across, we're going to put 8x. Now we're going to go back to our original numbers, our a and c terms. So that's 2x squared and negative 24. So now we just have to factor it. So between negative 6x and negative 24, we can pull out a negative 6. And then negative 6 times x is going to give me negative 6x. And then negative 6 times 4 is going to give me negative 24. And then x times 2x is going to give me 2x squared. And then 2x times 4 is going to give me 8x. So now that I have those values, I'm going to rewrite it, x plus 4, because that's positive, and then 2x minus 6, and that's going to be equal to 0, because again, it's a quadratic. So then I just solve. So x plus 4, I'm just going to take the opposite, which is going to be -4. And then for 2x minus 6 equal to 0, add 6. 2x equals 6 divided by 2. And we're going to get x equals 3. So we have x equals -4 and x equals 3. So now we just substitute these back into the easier equation. So between these two, y equals x plus 1 seems to be the easier equation to substitute into. So I'm just going to work on the bottom a little bit. So we have our table again. So on one side, we're going to have where x is equal to -4, other where x is equal to 3. So we're going to plug in. So y is equal to x, and in this case x is -4 plus 1. So -4 plus 1 is going to give us -3. So that means that when x is -4, y is going to be -3. So -4 comma -3. Now when x is 3, we're going to plug that in again. So y equals x, in this case x is 3, plus 1, we're going to get y equals 4. And when we get that, that means that when x is 3, y is going to be 4. So these are our two solutions. And we can verify because if we look back at our model, we can see we have 3 comma 4. Is that right? Yes, it is. And we also have -4 and -3. That's also right. And that's how you can verify.